Hi everyone. I hope you guys all had a wonderful Thanksgiving and it's time to get back to work. So today we're going to talk about parts of triangles. In particular, we're going to talk about segments of triangles. So the first thing we're going to talk about is what the triangle mid-segment theorem is. So first of all, let's identify some parts of the triangle. So the mid-segment is going to connect the midpoint of the two sides of the triangles. So notice here, point D is the midpoint of AB, point E is the midpoint of EC. Okay, and so that line or that segment is what we call the mid-segment. And so what the triangle mid-segment theorem is saying is that if you have this mid-segment here, then two things are going to happen. One is going to be parallel to that third side, and two is going to be half the distance or half the measurement of that third side. So if I were to write it here, we can say DE is equal to half of AC, or we can say it vice versa, or we can say 2 times DE is equal to AC. And one other thing we get from here is because these are parallel, that means this angle here is going to be congruent and corresponding there, and this angle here congruent corresponding there. Alright guys, so let's go ahead and try some of these problems. So the first thing they're telling me is that F, G, and H are all midpoints of the side of this triangle. So if F is a midpoint of CE, that's telling me these two segments are congruent. If G is the midpoint of CD, then these two segments, and if H is a midpoint, that means these two segments are congruent to each other because they're all midpoints. And so the other thing I'm going to do is I'm going to go ahead and highlight my parallel sides, right? So here's mid segment, and that's the third parallel side. Mid segment, third parallel side. Mid segment, third parallel side. All right, so let's go. They're telling me that FG is 9, GH is 7, and CD is 24. So remember how they're related is that the mid segment is going to be half of the measurement of that third side. So if we start with there, or if we start with that, then 24, which is CD, the third side, the mid segment is going to be half of that. So that means that's going to be 12. And because these two segments, so from C to G and G to D, they're supposed to be congruent. So we take 24 divided in half, that means each one is 12. Same with GH. So the mid segment, that's 7, and that means the entire thing is going to be double that. So 14 or 7 and 7, right? Because that is going to be twice or half of the mid segment. And then this would be 9 and 9 because the mid segment is 9, which means the entire thing is going to be 18. And so now we can go back and answer these questions. So CE is 14, DE is 18, FH is 12. And I want us to find the perimeter of triangle CDE. Triangle CDE is the big triangle. But I want to show you guys something. So the triangle, the perimeter of the triangle FGH. Okay, so we got 9 and 7, that's 16, plus 12, that's 28. That's the small triangle. And then the perimeter of the big one. So we got 24, 14, which is 38. Okay, so 38 plus another 18, that's going to be 56. So the perimeter of the big triangle is 56. What do you notice about those two? That is either half of the big one, right? Or 2 times the small one. So the properties still apply to the mid segment, right? Because it's essentially the same side, it's only half of the measurement. So whenever you know the perimeter of the big triangle, then the perimeter of the smaller triangle, if you have mid segments, it's going to be half of that, or vice versa. If you know the perimeter of the smaller triangle, then the perimeter of the big triangle is going to be twice that. So I want you to go ahead and pause the video and try this problem on your own. For my class, put the answer in a new discussion, and then once you put your answer in the chat, continue the video and see if you got the right answer. So I hope you actually paused the video. So it says L is the midpoint, which means those two are congruent. M is another midpoint, so those two are congruent. N is a third midpoint, which means these three are congruent. And then it says PR. So this entire thing is 46. PQ is 40, and LN is 17. Find the measure of each. And so once again, we break it down. So this is going to be 20 because that is the mid segment. And that's the side that's going to be parallel to the third side. So if LN is 17, that means QR is going to be 34. If PR is 46, that means LN is half of that, or 23. And then we can go in and fill each one of these. That's 20 and 20. This is going to be 23, 23, and 17, 17. And so each one of these, so LM is 23, MN is 20, QR is 34, MR is 17. Awesome. Moving on. So here's another, the same type of problem. The only difference is now we have expressions, right? So they're telling me that MN, NO, and MO are all mid segments. So if they're all mid segments, that's telling me that all of these are going to be congruent to each other, right? And it wants us to find the perimeter of JKL, so the big triangle. But we only know, or we only have information for here and here that can potentially help us because, or I mean, essentially we can also find this long one, right? So on and so forth. But remember, the area, or sorry, the perimeter of the smaller one is going to be half of the big one, or the 2 times the area, the perimeter of the small one is going to be equal to the perimeter of the big one. So that's what I'm going to go with. So I'm going to find X so I can find the measurement of MO. So that's the side that I'm going to go ahead and find first. So I do that by setting up my equation. 6x minus 1 equals to half of 13x minus 10. Now, I don't want to deal with the fraction of half of 13. So instead, I'm going to multiply by 2 on the other side to get rid of my 1/2. And I'm going to solve it that way. So when I distribute, that's 12x minus 2 equals 13x minus 10. I'm going to go ahead and move x to the other side. So subtract 12 and then add 10 at the same time. And that gives me x to be 8. Once I know that x is 8, then I go ahead and substitute it in there. And I get 6 times 8 minus 1. And that's going to give me the measurement of MO. So we got 48 minus 1 gives me MO to be 47. Now that I know that this is 47, then I can find the perimeter. So we'll say perimeter of triangle MNO. I know that's not the one we're looking for, but we know that the perimeter of that one, if we multiply by 2, is going to give me the perimeter of the big triangle. So 49 plus 47 plus 42 gives us 138. So that's the perimeter of the small triangle. Since I'm looking for the perimeter of the big triangle, I simply multiply by 2 and I get the perimeter of triangle JKL, which is going to be 276. Okay. So here we have what we call the perpendicular bisector theorem. And what it's saying is, well, let's break it down first. So perpendicular means it creates a 90-degree angle. A bisector means it's going to cut something in half, right? So cut in half. And so the perpendicular bisector theorem states that if a point lies on the perpendicular bisector, right? So here's my perpendicular bisector. Then it's going to be equidistant from the endpoints of that segment. So what that's saying is that if here is my original segment AB, and if I draw the perpendicular bisector, which is CD, then one, yes, these two are congruent because that's what it means to bisect something, right? But then it's telling us that this side here is going to be the same distance at that side there, right? And it doesn't matter where that point is at, as long as it's on the perpendicular bisector, then those two sides are going to be congruent, right? So if my point was there, then these two distances would have been the same. If my point was way up here, then those two distances would have also been the same. So it doesn't matter where that point is, as long as it's on the perpendicular bisector, then that statement is always going to be true. In other words, these are always going to be congruent. And the converse, right? So the converse of the perpendicular bisector theorem states the same thing. It states that if these two distances are congruent and you have a perpendicular segment, then these two are going to be congruent, right? So I guess you can think of it as the original one gives you these sides to be congruent. The converse of that gives you these sides to be congruent. And so we also have what we call an angle bisector theorem, right? So kind of the same thing. Perpendicular bisector, it means it bisects a segment. Angle bisector, we're bisecting an angle. It says if a point is on a bisector of an angle, then the point is equidistant from the side of an angle. One thing we got to remember is that whenever we get to that point, how we get to that point, it has to be perpendicular to the side of the triangle. So that's kind of what we have here. If that's the case, then the two segments are going to be congruent. Now, the reason why it has to be perpendicular is because, well, let's say we want our point on the angle bisector is there, right? If it was not perpendicular, then that means that I could have started here and then this one could have gone here. Although they both get to the same point, they're not going to be the same distance. And so if we state that they have to be perpendicular, then there's only at a certain point, there's only one way to get there. And the converse of the angle bisector theorem gets you the same thing. The only difference is now we start off knowing that these two distances are congruent and that it's perpendicular to the side, if we start off knowing that, then what we get from that is that these two angles are going to be congruent. Okay, so the original one starts off knowing that angles are congruent, and we get that the distances between the point and the side are congruent. For the converse, we start off knowing that the sides are congruent, and that tells us that the angles are congruent. Alright, so let's go ahead and try some of these problems. So right off the bat, so the first one, we have measure of RS, or they want us to find the measure of RS, which is here. And so we know RS in terms of X. So what we have to do here is we have to figure out what is X. Using the perpendicular bisector theorem, and we recognize that because we have two corresponding congruent sides there and perpendicular angle there, which is telling me that these two are going to be congruent to each other. So that's going to set up my equation and solve for X. So I state 7x minus 22 equals 4x plus 5. Subtract 4x from both sides. Add 22. Divide by 3, and we get x to be 9. Once we know what x is, we simply substitute it back in, and we solve or simplify. So in this case, 36 plus 5 is equal to 41. So RS, we're good there. All right, checking the second. So this next one, they want us to find the measure of AD, right? So two key things here. One, that's perpendicular, and these two are congruent, which means that's the angle bisector. So here we can apply the theorem and know that these two segments are going to be congruent to each other. And so knowing that they're going to be congruent to each other, that's how we're going to set up our equation, and we're going to solve for x. So subtract 8x minus 13, that gives us 5x. Add 4, that's 15. Divide by 5, and we get x to be 3. And once again, to know what x is, we simply substitute it back in for x. So we got 13 times 3 minus 4. 13 times 3 is 39. Minus 4 gives us 35. So AD is 35. And once again, we can substitute it in for the other one, the other side, just to double check that we got the right answer. We should also get 35. So 3 times 8 is 24. 24 plus 11 is indeed 35. Alright, so I want you guys to try this one, and put your answer in the previous post that you put. So just go back and reply to your old comments and give me the answers for each one. So for the first one, give me the answer to put EG equals, and then the second one, put measure of angle XWZ equals. All right, and then resume the video so you can check whether you got the answers right or wrong. So go ahead and pause the video now. So I hope you actually paused the video. And so here we have the converse of the perpendicular bisector theorem, right? So we start that the two sides are congruent, perpendicular there. That's telling me that these two sides are also congruent. So to solve for x, we're going to set those two equal to each other. Subtract 2x, add 37, divide by 12, and we get x to be 4. And once again, once we know what x is, simply substitute it in there and simplify. So 2 times 4 plus 11. So 2 times 4 is 8. 8 plus 11 gives us 19. So here, EG is 19. And so then we go over here to the second problem. So two key things: perpendicular, that's congruent, which is telling me these two are going to be congruent to each other. And so by the angle bisector theorem. And so if they're congruent to each other, we set those two equations equal to each other. So 3x plus 3 equals 8x minus 32. Subtract 3x from both sides. add 32 to both sides, divide by 5, and we get x to be 7. Once we know that x is 7, I have to be a little bit careful. So xwz is this angle here. So we simply plug it in there. 8 times 7 minus 32. So that's 56 minus 32 gives us 24. Awesome. Okay. So quick summary. So the triangle mid-segment theorem. Okay, so that we get two things off of it. Well, really three things. So here we get that we have parallel lines, right? So here we can say DE is parallel to AC, correct? So that's the first thing we get. Because these are two parallel lines, and technically we have two transversals, then this angle is going to be corresponding and congruent to that angle there. And same on the other side. So these two angles are going to be corresponding and congruent to each other. The other thing that we get is we get a proportion, or the ratio between them. So we get that segment DE is going to be equal to half of the segment of AC. Or we can say it backwards, or see it backwards. So we can say the big segment AC, so the big one, is going to equal to 2 times the smaller one, or 2 times the mid segment, right? And then that right there is called the mid segment. It connects the midpoints of both sides. For a perpendicular bisector, we get that if we start off knowing that we have two congruent lengths, right, and the perpendicular, then we can say that the sides are going to be congruent. And for angle bisector theorem, we start off knowing that if we have angle bisector and it's going to be perpendicular, then the two sides are going to be congruent, right? And the converse states the opposite of this. So converse would be knowing the sides, then we get the angles. For the converse of the perpendicular bisector, knowing the sides, then we get those.